Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 6th students of all participant branches for today's session. So as you all can see on the screen and you are well aware, my subject is physics. We are in class 6th. Our ongoing last chapter, pressure. Today we are in session number 3. So far we completed 2 sessions last week to understand the basic concepts of pressure. So first, before going for the today's topic, we'll recall what we learned so far in last 2 sessions. So we learned about what is force, what is thrust, what is pressure, continuation, and what is the applications of pressure and various examples of pressure through video, and also introduced about the fluid, what is fluid and what is the fluid pressure. Just introduction part you have done, right? So these are the basic concepts, basic topics what we discussed in the last 2 sessions. So later coming sessions we'll discuss about the what is fluid pressure, that is pressure in liquids and gases. Fluids are nothing but matter which flow. As you know, solids does not flow, only liquids and gases can flow. So both liquids and gases together called fluid. So how the fluids will exert the pressure and what are the day-to-day observations we can make for fluid pressure and how this is applicable industrially. Everything we'll discuss in the coming sessions, right? So when you move the slides here, this is the first what we discuss about the thrust and pressure. And what are the units of the pressure which are generally measured in Newton per meter square or Dyne per centimeter square or Pascal, bar. So many units are there. And we have seen how the pressure depends on the area of cross section or area. Based on that applications also, while you are skating on the ice and while you are inserting nail into the wall. So many examples are given where pressure comes into play. Okay. So now when you come to the synopsis 2, now today we are going to the synopsis 2, which is about the fluid and fluid pressure. Pressure in fluid. How liquids and gases exert pressure. So there are 3 kinds of pressures exerted by the fluid, like liquids. First we'll discuss about liquids. The one is downward pressure, upward pressure, lateral pressure. That is also called sideward, which you can see through this diagram. Suppose when you are dropping any heavy body into the water, it will get inside, completely sinks inside. Here it is sinking because of the upward pressure. Right. Here it is, see how when you are making holes, you are getting the pressure from the all sides, which is lateral pressure. And fourth case, see, when you are push the ball inside the water and leave it, it will come up. It is floating. The floating is because of the upward pressure, which is also called, I told already, upward pressure is also called buoyancy. Right? Force of buoyancy or buoyant force. See here, we are inserted the football into the water. We are released. When you release, what happened? Because of the upward pressure of the water, football will come to again to the surface like this. It floats because of the upward pressure exerted by liquids, right? So these are the 3 kinds of possible pressures exerted by the liquids. Clear? Now, when you see the mathematical explanation, so in mathematical explanation for the pressure, you can see here. Okay, so here we got the formula. I'll tell you how you got it. So pressure is equal to, we know, force by area, right? Correct or not? So pressure is equal to force, you can write mass into acceleration by area, right? Mass into acceleration by area. Correct or not? Because second law says that F is equal to ma or mg, you can write. So what is mass? If you recall, density is equal to mass by volume. Rho, this is not P, rho. So mass is equal to volume into density. Density into volume. Substitute here. So you can get density, volume, G by area. Right? Correct or not? Density, volume, G by A. Because in place of M, you substitute rho into V. So rho Vg. Clear? So volume, again, some more change you can write. From here, rho, volume we can write as area, that is area into length. Because volume is nothing but length into breadth into height. Length into breadth into height. Na? So you can length into breadth into height, you can write. So height. So length into breadth, you can write area. Height as it is, we kept. G by A, area. So area cancel. So how you got this is very important. Area into height. Because volume is nothing but length into breadth into height. So length into breadth is nothing but area. We written here. So area cancel to get the pressure is equal to rho GH formula. Rho is nothing but density, G is nothing but acceleration due to gravity, H is the height. So pressure exerted by the liquid depends. Of course, G is constant, depends on density of the liquid and height where it is, whether it is inside the liquid or above from the liquid, the height it considers. So from that, we got the formula here. H rho G. H rho G or G rho GH. This is the mathematical expression for the pressure, which is obtained from simple definition only. P is equal to F by A. I will explain you can note down this derivation. Okay. I'll explain you. Put it in your notebook. Very important mathematical formula. I'll put it on wide screen. I'll explain clearly for you here. Right? Okay. Write down. All of you note down. Expression for pressure. For pressure. In brackets, you can write liquids. The formula for liquids only. Right? So first, we know P is equal to force by area. Right? But force is equal to mg from Newton's law. Mg by A. Right? So we got P is equal to, note on all of you, mg by, otherwise you will confuse, A, which is equal to M, what can you write? Density into volume, G by area. In brackets, you can write density is equal to mass by volume formula. So from this, mass is equal to density into volume. This is in brackets. Okay. Then P is equal to, here rho as it is. In place of V, I wrote A into H into G. How it is, can write. So volume is nothing but length into breadth into height. So in place of length into breadth, we wrote area into height. Right? So by A again is the A. So you can cancel out A and A. Therefore, P is equal to H rho G. Rho is density. Don't confuse. P is the pressure. Rho is density. So H is equal to height. Rho is equal to density. And G is equal to acceleration due to gravity. Right? So note all this. Mathematical expression for pressure of a liquid. Right? Good to see Gidalur, Mani Block, Medichal, Oakley, Ramnagar branch, Swarup Nagar branch, Bhudevi Nagar, Falaknama. I don't know what is another. TMS and Pooja Reddy. I don't know which branch you are. Please mention the branch name and school name so that we can identify you, not with personal names. Right? So we got the formula, mathematical formula for pressure exerted by liquids. So whenever the density of the liquid is given, height is given, you can find out the G is constant anyway, you know, 9.8 meter per second square or 10 meter per second square. We can get the how much pressure that liquid can exert. Means it purely depends on density of the liquid. So pressure of water is different from pressure of mercury, pressure of kerosene, pressure of alcohol. They are different because they have different densities. Right? It purely depends on density because G value is constant anyway. Of course, it also depends on height. From where you are dropping. Right? So before going for the further explanation, let me show you some basic videos on about fluid pressure. Right? Here we are. Before going for the law of pressure, before discussing about law of pressure, let me show you videos on the based on the same pressure.
Have you ever wondered why a large ship floats but a small pebble sinks? In this video, we'll learn about floating, sinking, pressure, and density. Density is a measure of how heavy something is relative to its size. It can be calculated using this equation. Try calculating the density of a wax candle that has a volume of 2 centimeters cubed and a mass of 1.9 grams. Pause the video to work it out.
Mass by volume we can write.
We can use density to predict whether an object will float or sink when it's placed in a liquid. If the object is more dense than the liquid, it will sink. If the object is less dense than the liquid, it will float. Water has a density of 1 gram per cubic centimeter. Will the wax candle with a density of 0.95 grams per centimeters cube float or sink in water? That's right, the density of the candle is less than the density of water, so it will float. Lead has a density of 11.3 grams per cubic centimeter, and liquid mercury has a density of 13.5 grams per cubic centimeter. What would happen if a block of lead were placed in a beaker of liquid mercury? Pause the video while you think. The lead would float in the liquid mercury. So that's a fairly easy way of explaining why solid blocks float or sink. There is another thing to consider: buoyancy force. All liquids are made up of particles that can slide over each other. When the particles collide, pressure is produced. The pressure in a liquid varies with depth and density and gravitational field strength. In a column of liquid, the water will pour out through the holes in the side of the container. The water that pours out of the hole at the bottom of the container travels further than the water that pours out of the hole at the top. This is because the water at the bottom of the container is under greater pressure than the water at the top. The mass of the particles pushing down on the water at the bottom of the container creates more pressure. The deeper the liquid, the greater the pressure. We can use these facts to derive the formula, where P equals pressure, rho equals density, H equals depth, and G equals gravitational force. Imagine a cuboid submerged in a tank of liquid.
It depends on height.
The distance from the surface of the liquid to the bottom of the surface of the box is greater than the distance from the surface of the liquid to the top of the surface of the box. So H2 is bigger than H1. Because P equals rho GH, the pressure on the bottom surface due to the liquid must be greater than the pressure on the top surface. This results in there being more force on the bottom surface of the box than there is on the top surface. The difference between these two forces cause there to be a net force upwards called the buoyancy force or upthrust. If the buoyancy force is greater than the weight of the object will rise up through the liquid. If the buoyancy force is less than the weight of the object will sink. If the buoyancy force is equal to the weight of the object will still float.
Okay. So what is that clearly explained about what is the pressure exerted by liquid. So one more video is there. More explanation about that.
When you hammer an iron nail, you apply force on the flat side of the nail. The pointed side of the nail, which is in contact with the wall, then applies the force on the wall and tries to pierce it. Now let me ask you an interesting question. What will happen if you hammer the pointed side and try to pierce the flat side of the nail? You will find it difficult to push the flat face of the nail through the wall even if you apply more force than you did in the first case. What is the reason for this? The reason is that the pressure applied by the tip of the nail on the wall is more than the pressure applied by the nail's flat surface. But the question is why? First, notice that the area of the tip of the nail is very less as compared to the area of its flat surface. This tells us that the area of the surface on which the force is applied matters. We will understand this in detail, but first let us define pressure. We define pressure as the perpendicular force acting on the surface of an object per unit area on which it's acting. It's easy. Force acting per unit area. We already know that the SI unit of force is Newton, denoted by N, and that of the area is meter squared. So the SI unit of pressure is Newton per meter squared. It is also called Pascal, which is denoted by PA. Why is it called Pascal? It is given this name to honor the achievements of a French scientist named Blaise Pascal for his contributions in hydrostatics and hydrodynamics. Observe the equation carefully. Area is in the denominator of the fraction. What is this area? Well, this area is nothing but the area on which force is applied. Say I keep the force constant and I keep increasing this area. What will happen to the pressure? Will the pressure increase or decrease? Use pure mathematical logic to answer this. If I have a fraction and I keep the term in the numerator constant and keep increasing the term in the denominator, then will the fraction increase or decrease? Surely it will decrease. So the pressure will decrease if I increase the area while keeping the force constant. With this newfound knowledge, let's go back to the example we saw earlier, the nail and the wall. Notice that we are also applying the force perpendicular to the surface of the wall. The angle between the nail and the wall is 90 degrees and not anything else. If you notice, the tip of the nail has a very small area compared to the flat surface of the nail, and hence the area of contact with the wall reduces to great extent in the first case. Hence, the pressure applied by the tip on the wall is greater than the pressure applied by the flat surface. That is why it is easy for the tip of the nail to penetrate through the wall. You can even use drill machines to drill the hole into the wall. You see that it has the pointed tip for the same reason. You can easily cut the vegetables using the cutting edge of the knife. But if you use the blunt edge of the knife, it will be difficult to penetrate it in. What is the reason in this case? Well, in the first sight, the two edges might look the same to us. But if you look at them carefully, the cutting edge has small triangle-like shapes with sharp outer points. The other edge has nothing of these. So if you cut a vegetable with a cutting edge, the area of contact between the vegetable and the knife is greatly reduced. Hence, more pressure is applied on the vegetables using cutting edge of the knife. Area used to cut the trees also have sharp cutting edges instead of placid ones. It increases the pressure on the tree due to the less area of contact. The examples that we've seen so far are applications of high pressure. It's about how high pressure is useful to us in some cases. But it is not
Pressure is
always the
applied.
case. There are situations where we require low pressure. Let us see some applications or advantages of low pressure. We use snowshoes to walk on snow.
See, very
The reason
interesting
for that is
application.
simple. Due to the larger area in contact with the snow, snowshoes reduces the pressure on the snow. We are able to walk on it without our feet sinking deep inside. In case of normal shoes, due to comparatively smaller area of contact, the pressure on snow is more and it sinks our feet deep inside. Note
cannot walk
that the
on
force
ice
applied on the snow in both the cases is the same. This force is nothing but our weight on the snow. Have you ever wondered why the wheels of an army tank run on the steel tracks rather on the ground?
See how
Notice that the wheels are on steel tracks and are not touching the ground. The army tank is huge in size. If the wheels run on ground, due to less contact area with the ground, the pressure on the ground will be massive. However, the tracks have much larger area of contact with the ground and hence the pressure on the ground is reduced to a great extent. In all the examples that we have seen in this video, it is the solid which is applying pressure on another solid.
So this is only about the solids and solid pressure, what we learned in the earlier 2 sessions. But right now also we discussed about, we have seen the video on liquid pressure also. So these 2 videos clearly makes you understand what exactly we learned in the last 3 sessions about the pressure and factors of pressure, how pressure depends on area, and then enter the mathematical derivation of the pressure. P is equal to H rho G, and then so what is the applications of pressure in our day-to-day life when there is a solid and solid is there. So liquids also we have seen, all the liquids are gases. Right now we discuss only about liquids, exert downward pressure, upward pressure and lateral pressure. 3 kinds of pressures. So after knowing this mathematical formula, we'll see about the laws of liquid pressures. After studying about the pressure of liquid, we can have some laws. Some laws are proposed. Laws of liquid pressure. Following are the laws of liquid pressure. Number 1, pressure at the point inside the liquid increases with the depth from the free surface of the liquid. So free surface means this top one. When you are going deep into the inside, as the body goes inside, the pressure increases. So, right. So pressure is directly proportional to height. Height from top only, from free surface. Free surface, when you go inside, suppose you are swimming on the surface of the water, then you will get the less pressure. But when you go to the inside the water, pressure of the liquid is more. It tries to push to the surface. So that clearly indicates that pressure of liquid is directly proportional to height or depth from the surface. From surface it is called as depth. From bottom it is height. Right? That is the first one. So second one is pressure at the point inside the liquid at the given depth increases with increase in the density of the liquid. So as the density of the liquid changes, the pressure automatically changes because it is also directly proportional to rho, density of liquid. Rho L you can write. So we know rho is equal to only 2 factors only, rho G, rho Hg. G anyway constant. Only these 2 are the main factors influence the pressure of liquids. Right? Then third one, pressure is same in all directions about a given point within the liquid. Very, very important point. This makes to the Pascal's law also. In all directions, pressure applied is same. Right? Same at all points in the horizontal plane, given depth in a given stationary liquid. A liquid seeks its own level. Right? So, again, some more points are there. Pressure in the fluid is independent of area of cross section, the shape and size of the container. Right? So, these are the independent, which does not depend. So, there are 3 important points which are together called laws of pressure, and there are some few important physical quantities on which pressure does not depend. independent. So these are all together called laws of pressure. Right. So we'll continue next class in details about the laws of pressure and other concepts of pressure. Like you can see here, atmospheric pressure, the next synopsis 3 will come across. Atmosphere, pressure exerted by atmosphere, right? Air in the atmosphere. With this is almost the last topic, which you are going to complete by next class. Okay. So far we have done with a good important concepts. We started learning with the first one is about force, about thrust, about area, about pressure, what is pressure, then applications of pressure, that is solid, right? Then today we enter into the fluids. What are fluids? Next, pressure in fluids. So there are 3 kinds of pressures again, right? Upward, downward, and lateral or sideward. 3 kinds of pressures we have seen, right? And mathematical equation for pressure, mathematical formula for pressure also we derived, that is P is equal to H rho G. Right. After deriving this formula, again we discussed about what are the applications, laws, we can call it as laws of pressure. Right? Laws also we discussed. So with this we have completed the 2 synopses of the chapter pressure. One more synopsis is there, followed by the solved examples, which will complete in the next class. Then you can go for the grand revision. Right? So these are all the topics what we covered in the last 3 sessions. Clear, all of you? Right. So that's all for today. You can see some home task, the practice all the level 1 papers which are going to come in the test number 8, which is on 24th of February. Right, all the level 1 questions about the first 2 synopses. You practice them from the material, go through the concept and complete the level 1 questions of all the 2 synopses, right? So that's all for today. Thank you all of you. Have a wonderful day. Thank you.